Okay, let's start. So this is your final run. It's actually just these four topics. Alternating current somehow just got into this book. It was supposed to be in the previous book. Anyways, so এটা আজকে start করবো. এটা বেশি বড় না. It doesn't take much time. But these four are arguably the most interesting branch of physics out there. Like out there, whatever physics exists, these four is probably the most interesting, but also a little challenging. Okay, so quantum physics, I mean, by the name, it sounds supposed to be something very interesting. Nuclear physics and radioactivity is your O-level stuff, but we review it. Medical physics, actually, practically, I feel is the most that you'll be facing in your life. But, whatever medical diagnosis out there, so you'll get a better idea of, what the different instruments do. Okay, and finally, astrophysics. Astrophysics, the problem is it's actually not very in depth. It's a continuation of your O levels. So there are some math that we couldn't do in O levels. Like astrophysics takes 2 classes. Okay, if I go slow. So yeah, so astrophysics is very limited. Medical physics is a struggle because there are 5 instruments that are working, and these are not just 1 or 2 marks. These are all 7 marks, and there's also a lot of math out there. Yeah, it's like a borderline between bio and physics. Right, let's start with alternating currents. So alternating currents are key থাকবে এখানে. So this is continuation of last class. Last class এটাই এখানে আসতেছে। এখানে বলছেন understanding of practical and economic advantage of transmission of power from your O levels is assumed. So we discussed this the other day. I'm just to recap for Renee. This is the need for what in your transmission grid? Transformer. Okay, so last class je transformer ta korছিলাম ওইখান থেকে we are continuing. Transformer ta ekhane ashe na, but it's something they want you to know. So what are you supposed to know in this topic? Just 4 very straightforward points. Understand and use the turn period, frequency, peak value for an AC voltage. Understand this representation for current, and mean voltage bole ekta jinish ache ota amra dekbo. This is very important. And lastly hocche tomar a root mean square voltage bole, there's this thing. And there's another thing that I'll be showing here, which is this one, rectification and smoothing. Okay, so this is like how you convert an AC supply to exactly flat line like that. Okay, so that's what the chapter is. So let's start. First part could be easy, beshi time nibe na. Right, so let's first try to understand the production of an AC supply. So we need to learn the working of a generator. Every time I ask you the generator, you guys start talking about the motor. So aage theke heads up de rakhlam. This is the generator. The generator is a device that utilizes which law of physics? Lenz's law or law of thermodynamics? Oddly, you guys are all right. very rare for that to happen. Because তোমরা যেটা বলছো, these are fundamentals of physics. এগুলো হইতেই হবে। আচ্ছা, third law কাজ করতে হবে, thermodynamics has to work, otherwise systems don't run, right? আর কি যেটা বলছো, Lenz's law কাজ করতেছে, okay? But not to the point that I'm asking though. So yeah, you have this your generator and or dynamo. It uses Faraday's law of electromagnetic induction, and the Faraday's law states that if you have magnets like that, and within the poles of your magnet, if you have a coil that rotates and the coil cuts the magnetic field lines, what will be induced? EMF, right? So that's what we saw. So to that, because we need to understand the AC nature of our supply. Okay, so look at this. You have this coil, and coil to check the basic flat coil use for practically we use different shapes. So yeah, this is your coil out here, and the coil is made to rotate, or is the coil going to rotate? Made to rotate মানে হচ্ছে আমরা কয়েলটাকে ঘুরাই, and going to rotate মানে the coil spins after we do something. Which one is this? Going to rotate. So going to rotate হচ্ছে মানে তুমি কিছু একটা করবে and it spins. And this is the generator. Generator, do you make it rotate or does it rotate? Generator. Acha, so generator bole oneke just you lose sense of reality. So a wind turbine. Okay, a wind turbine. So wind turbine ki tumi current de atmosphere ke thanda karo naki it's like wind comes along and spins it. What happens? Right. Okay. So it spins and then something happens, right? So we are using some external factor to spin it, right? So ekhane jeta kora hoy is we take our coil here and we connect it to your rotor. This device is called a rotor. Basically, it spins. Now, it can have blades of a fan. It can be a wind turbine. It can be water falling onto it. It can be steam going over it. Eventually, the thing that you need to understand is that it can have blades, and these blades spin very fast. And as the blades spin very fast, what happens is that the coil here rotates. Okay, so আমার যে কয়েলটা আছে এখানে রোটেট করবে ভিতরে now as the coil rotates what does it do it goes downwards on this side and upwards on that side the rotation of the coil causes the magnetic field lines that are within the magnet to be what cut so these are the field lines that are out there ogla cut hobe and as the field lines are cut what is induced in the coil EMF okay so yeah that's what's going to happen now you need to know what's the direction of the current because it's a bit good so I'm going to show you some values here so this pole that you see here this is your north pole and the pole that you see on this side this is your south pole question is what happens to the field lines they're being cut right and there's EMF induced can you tell me the direction of the EMF induced only in this wire I'm going to wire take a focus this is A and this is B what is the direction of the EMF induced in that particular wire? Is it so current flow so let's say would the current go from B to A or A to B? How do you find this? So to find this, you use Fleming's left-hand rule and find the direction of the current and then what that? Reverse that or you use what? The Fleming's right-hand rule. Okay. So এটা হচ্ছে induction. For induction, which rule should you use? এটা হচ্ছে EMF is induced, right? EMF induced এর জন্য which rule do you use? The Fleming's right-hand rule or the Fleming's left-hand rule? Okay, and there's another rule out there which is the motor effect. Motor effect what do you use? Fleming's left-hand rule. So anyways, let's figure this out. FBI, B is north to south, force is upwards. So if the B magnetic flux is north to south and your force is upwards, right? The current here goes from B to A if you use your left hand. But this is the induction effect, right? Induction, the answer is always going to be what? The opposite, right? Correct. So online it was right. It'll go from where to where? A to B. So you'll actually have current flowing in this coil in this direction, A to B. And on the other side, current will naturally flow which way? The other direction, right? So let's say take C day or D day, current will flow from C to D. Do you follow? আচ্ছা, now the thing is, this is a generator and it's going to spin. As it spins, there will come a moment where the coil in the center looks like this. I'm coil to rubber, okay? The coil in the center is going to spin and it's going to become vertical. So you need to figure out এটা যখন vertical হয়, what is the EMF going to be? And you also need to figure out when it's at an angle, what is the EMF going to be? So at an angle টা কি হবে একটু explain করি। এটা diagram ছাড়া বুঝে না discuss. I'll just take this part here. So yeah, the thing that you see here, this is the coil's orientation right now. আচ্ছা, এই যে এরকম। And right now, this is the original layout of your coil when it was what? Flat. কিছুক্ষণ পরে কি হবে, এটা রোটেট করে করে ইট উইল বিকাম স্লাইটলি লাইক দিস। এই যে এটা উপরে নেমে যাবে, উঠে যাবে, আর এটা কোন দিকে চলে যাবে? নিচে। And as it does that, the coil will now appear to be slightly what? Tilted. এই যে এরকম slanted হয়ে যাচ্ছে। Can you visualize what I'm trying to show here? So coilটা কিন্তু এখন হচ্ছে পুরোপুরি horizontal না, coilটা পুরোপুরি কি না, vertical না। At this moment, the force is going to be like that. এই যে এই ওয়াইটের সাথে perpendicular, মানে হচ্ছে if I draw a line like this, the line and my force will produce a what angle between them? 90 degree, right? So this is the angle. So the question for you is, what is going to be my EMF here induced? Is it going to be maximum, or is it going to be zero, or something in between? Something in between, right? And what about the vertical one? The efficiency of the efficiency of fuel. No, it's just directly how much electricity you get from it. That's the energy at the end, right? Yeah, so you can actually manipulate that and make it more efficient. So let's say you spin something and then it's spinning at a certain rate. Now it's one coil spinning at a certain rate. If you have 10 coils spinning at the same rate, wouldn't your output be higher? So you can improve the watt of your motor efficiency. But there's a like a sweet spot. As you keep increasing the number of coils, right? What starts to become more? The weight of the coil, the resistance of the coil. So at a point peak করে আবার যখন তুমি coil বাড়াচ্ছো, it starts to go down. So there's like a golden point at which you have the highest output. So it's not like if you keep increasing your number of turns indefinitely, the voltage will keep increasing indefinitely. There's actually a sweet spot out there. Same goes with wind turbines. You'll always find that how many blades they have. 3, right? Why not more? Because they have found that the moment you have 4 blades, the thing becomes too heavy. And when it's 2 blades, it's not really cutting enough field lines, or it's not spinning fast enough. So they found 3 is like the golden ratio. And so you'll find the fans in your house, they have 3 blades, right? Why not give like 6 blades? 6 blades actually won't give you more air. 3 blades give you the highest amount of air. So there are fans that have 4 out there, right? They're actually not more efficient. I don't know why they have them. They're supposed to be, the 3 is like the perfect number. কারেন্টটা কেন ওদিকে যাবে? এটা তো হচ্ছে জেনারেটরের মধ্যে তো হচ্ছে Faraday's law of electromagnetic induction. ওইখানে whatever you anticipate একটা মাইনাস সাইন থাকে, অ্যান্সারটা উল্টে যায়। তো তুমি লেফট হ্যান্ড রুল দিয়ে যখন অ্যান্সারটা বের করবা, যেটা হওয়ার কথা, জেনারেটরে the answer is always the other way around. তার জন্য এটা উল্টো দিকে যাচ্ছে এই জেনারেটর। হ্যাঁ, সো তুমি লেফট হ্যান্ড রুল ইউজ করে উল্টা করতে পারো, অর ডাইরেক্টলি ইউজ করতে পারো, রাইট? এই যেটা, হ্যাঁ, সো এই যে FBI, so F is upwards, B is north to south, FBI, north to south. So as it goes down, এই যেদিকে আমার হাত দেখো, এটা কি নর্থ টু সাউথ? ফোর্স উপরের দিকে, আমার ফিঙ্গারটা এদিকে যাচ্ছে, from where to where? A to B. তোমার রাইট হ্যান্ড দেখাও, আমি তাহলে সেট করে দিচ্ছি and do the thing. হ্যাঁ, সো থামটা উপরে রাখো, থাম থেকে মুভ করবো না, ওকে? FB ম্যাগনেটিক ফ্লাক্স হচ্ছে তোমার, আই থিঙ্ক তুমি হচ্ছে ঠিকঠাক করছো, হ্যাঁ ঠিক আছে। তো তোমার এইটাকে তোমার পয়েন্ট অফ ভিউ থেকে কিরকম দেখতে? হ্যাঁ, ওই রেড অ্যারোটা ইন্ডেক্সে এদিকে পয়েন্ট করো। হ্যাঁ, রাইট হয়ে গেল। সো তোমার মিডল ফিঙ্গারটা কোন দিকে? Here, right? So that's like A to B. Okay, anyways, let's get done with this. It actually all level at recap for us, but clarify going. So you see here, there's an angle generated, and the thing is not perfectly cutting the field lines. So if you look at the field lines here, you'll find that your object is what to the field lines, not 90-degree, but not what either, parallel. But if you go to the scenario here, এখানে নোটিস করবা তোমার যে কয়েলটা রোটেট হচ্ছে at this particular instant, which way is the arrow pointing here? This way. And which way are your magnetic field lines? They're also in that same direction. So what is your magnetic field lines compared to your movement? Parallel, right? So bottom line হচ্ছে যেটা all levels থেকে নিয়ে আসতে হবে, at this particular orientation, the EMF induced is going to be what? 0, okay? And এখানে তোমার EMF যেটা induce হবে, it's not going to be 0, it's not going to be maximum either. So it's going to be less than V max, but greater than what? 0, right? So okay, why did I show this? I'll show you in a minute. And this one is the one where your EMF is going to be what? Maximum, okay, V max. Because at this moment, if you look at the movement of your coil and if you look at the field lines, what are they to each other? Perpendicular. So the question is, why did we learn this? It was the start of our chapter. It is the O levels requirement data ওইটা fulfill করতেছি। এটা করার পরে if you draw a graph for voltage versus, let's say, time, the graph will look like a sinusoidal graph, a sine function. And students sometimes wonder, why is it a sine function? That is because the magnetic field that is perpendicular to this coil is following that formula, phi equals to BA sine theta. Remember, there was this formula where phi the field lines need to be what to the surface? Perpendicular. But if my surface tilts, what are perpendicular to the component and the component follows a what function? Sine function. So eventually, it's not something that's very important for you, but just if you're wondering. So the voltage that we get from here, the EMF that's induced versus the time that's taken, gives us a graph that looks like this. Now it could be a sine graph or a cosine graph, because you should know by now that a sine graph and a cosine graph are what graphs? The same graph, okay? It's just that they're shifted. Shifted in what way? 90 degree. মানে তুমি কোথা থেকে start করতেছো ওইটার উপর depend করে. So this is your function. Now you need to pinpoint for me যে কোন পয়েন্টে কয়েলটা কিরকম দেখতে। এটা হয়ে গেলে we can start our topic, okay? So can you tell me at this point where my EMF induced is 0, right? How does the coil look like compared to my field, and how does the movement compare to my field? আচ্ছা, আমি একটা বলি আগে, my coil and my field are what orientation when the EMF is 0? Very good, right? It's actually perpendicular. The movement is what? Parallel. A common mistake ki hai, student eta dekhe and they think that, oh, look at the coil, it is what to my magnetic field lines here, perpendicular, right? But that's not what we look for. We look for the what of the coil, movement of the coil. Movement of the coil is what to the field? Parallel. You know, when it comes to EMF induction, what is important? The orientation of your coil or the movement of your coil? The movement. And in this particular scenario, since the movement and my field are parallel to each other, what is the EMF going to be? 0. Here, students commonly make this mistake. They'll think, oh, look at this, my coil is flat, my field is flat, so the EMF must be what? 0. But no, the EMF is actually what here? Maximum, because even though my coil is flat, the movement of the coil to rotate করতেছে, this wire right now is moving which way? Up like that, which happens to be what to my field? 90 degree, right? Wouldn't that mean that I have the highest cutting ability out there? So imagine this, okay? Remember here, there's a field line like that. This is the field line. How can I cut the field line most effectively? If I take this surface, if you think of this surface, this is the coil, right? A coil right now, it's gonna spin. This book is gonna spin. This is the coil right now. When the coil is like this, what is the coil to the field line? Parallel. But এটা কিন্তু হচ্ছে rotate করতেছে. So if you look at the edge, isn't the edge perpendicular to it? Think of lines coming out from the edge like that, right? Wouldn't that mean that this and that are perpendicular to the field? So at this particular orientation, you'll have actually the greatest EMF. And as it rotates and rotates and rotates and goes that way, right now the coil is what to your field lines? Perpendicular. But if you put an arrow here to see which way it's moving, how is it moving in relationship to the field line? Parallel. So therefore, there's no EMF being induced, right? So if I do this in this motion, right, as I do that at the top, my movement is what to a field line here? Parallel. But if I do this and go down like that, isn't that perpendicular? So remember that আমাদের যে এখানে EMF টা হচ্ছে maximum, এটা হচ্ছে because of this orientation where the coil and your movement are perpendicular. And the field line is like this. So this is how the diagram should look like. As it goes to the top, how does that look like? So যদি উপরে যায় এই জায়গাটায় field তো এরকমই থাকবে. This is going to become like that. The coil is now what to the field? Perpendicular. But what is the movement to the field? Parallel. Okay, so আমরা কোনটাকে check করব? The arrow and the red line, not the coil. So the arrow represents the what of the coil? Movement. Achha, this is the movement. And the red line represents the what? Field. And the black line here, or a color change with it, let's say. Yeah, you're right. Eta hobe hocche the green line is going to be your coil orientation. No, আমি বুঝছি, আমি মানে you're saying যে এটা এখানে হওয়ার কথা. I'll shift it right now. I'm just label করতেছিলাম. Yeah, you guys happy? So yeah, that's right. And এই জায়গাটা যখন আসবে তখন হচ্ছে কি হবে? You have the maximum value, right? So maximum value মধ্যে what's going to happen? This thing that you see here is going to be perpendicular to the field, but the coil is going to be what to the field? Parallel. So we don't care about the coil orientation. That's what I'm trying to say. Okay, visually mono the coil and the field are parallel, but the movement is perpendicular, and that's what matters, right? Again, you'll have this thing here. It is our 0, but this time, how is the coil moving? Yeah, it's actually like that. Because now it has spun all the way around, right? So there you have it. And at that bottom part there, this is going to be exactly same thing, but which way? Downwards. Does that have any consequence? That the whole coil is moving downwards like that? So yes, it'll produce an EMF that is of what polarity? Opposite, right? So you can do your positive high, what would that generate? Negative. And this is basically the whole cycle that you see here. So the reason why your AC supply produces a sinusoidal wave is because as the coil moves, it moves in such a way that it keeps changing its path, following a what function? Sine function. So as you plot the variation, you'll find that it gives you a sine graph. Now, what if I started my graph from this moment? It'll go like that and it'll form a what graph? Cosine graph. That's sine, cosine is not important here. The term and the word they use is sinusoidal. Sinusoidal means sine, cosine, দুইটা use করতে পারো. Okay, so yeah, this is the graph. Now, একটুকে কোনো confusion থেকে আমাকে বলতে পারো. I'll add your O-level notes here because O levels recap করলাম. A levels এখন start করবো. Okay, so are you clear about the fact why is it like a sine graph or a cosine graph? So what's in our A levels? So A levels say we need to understand the mathematical representation of this. So eta, I personally feel, is something that you should know from math. So math একটা sine functioner equation টা আমাকে একটু বলবা? I don't want you to memorize this thing because you already know it. Huh? A sine bx plus c. আচ্ছা হ্যাঁ আচ্ছা বুঝছি কি মিন করছো হ্যাঁ ঠিক আছে that's do you guys learn that আচ্ছা interesting ওখানে like the plus secant this is হ্যাঁ বুঝছি so do you know how to translate and do you know how to deal with coefficients inside your function আচ্ছা তাহলে তো এটা খুব ইজি হবে তোমাদের জন্য আচ্ছা so this is my voltage or voltage now this is y axis this is x axis আমি একটা সিম্পল কোয়েশ্চেন করব মনে হচ্ছে তোমরা পারবা ওইটা হচ্ছে tell me the equation for this function y or x use করে y equals to yes okay good now I want to amplify the graph মানে হচ্ছে গ্রাফের হচ্ছে ভ্যালুটা এখান থেকে let's say half করতে চাই বা ডাবল করতে চাই what will I introduce to this equation right so আমার এখানে এই যে এই ভ্যালুটা যদি হচ্ছে এটা হয় let's say b what should the equation be yeah so y equals to b sin x are you clear about that okay now can you tell me what would happen if I introduce a x এর সাথে একটা coefficient let's say the coefficient here that I introduce is a what would this equation look like what will happen to my graph huh it will stretch in the x-axis by what amount a তার মানে every huh? a by 2 কেন x এর আগে যেটা হয় a by 2 কেন 1 by a হবে what is this a by what do you get 2 from I was confused I was like trying to figure out where is 2 in this equation yes that's 1 by a হবে correct acha so yeah I mean তোমাদের মনে আছে ভালো not bad এখন let's say that you didn't have additional math in your O levels right so for those students physics we have a way out a number of turns oh acha ha tamare to tomar graph ta hocche shrink kora hocche because in that same time frame aren't you having more number of turns okay I mean to let's cut to the chase here so whenever you have a function that is a AC voltage induced right what are the equation hocche ora diye dito tomoderke like you know you don't need to know the fundamentals of math you just have to use a format ta shikhe tomoderke so let's say I have my AC supply here it produces a graph like that and it's been generated by a generator in a power station so আমাদের যে বাসায় electricity আসছে right now it's coming from a power station ওই power station মধ্যে there's this generator spinning right now at this moment and it's producing electricity couple of things you need to know the power that we get here right it has to be an AC supply can anyone tell me why you can't really supply DC supply kora is something that was very famous in the 1900s and they realized that it's actually not feasible and then somebody worked on this called Nikola Tesla he came up with the idea that you can actually transfer power right using alternating current and not have what loss energy loss right so what's the issue with transferring electricity by DC supply no that's DC is flat so why don't we use DC transformer jonno হ্যাঁ হিট আপ হয়ে যাচ্ছিল আচ্ছা ওকে তাহলে how did AC fix that transformer acha I will take your answer so basically what happened was this is 1910 there's this person called Thomas Edison he basically came up with the filament lamp and what he did was he did like a road show he took a train mode he put up filament lamps and he took the train all across USA like everywhere and people saw that and bought the idea that lamps bashay thakbe because before that they used to use candles okay now he said to run the lamp you need electricity and where can you get electricity he also like you know just coincidentally had batteries with him so সবাইকে বলছে তোমরা এই ব্যাটারি যদি কিনো then you can run your lamps right and these are very big batteries এই ব্যাটারি গুলো সাইজ হচ্ছে ধরো টিভি সমান they would last like a couple of weeks right and then what do you need to do replace them so that's when they thought একটা টাউনে আমরা কি করব অনেক ব্যাটারি কিনবো and we'll keep all the batteries in one place and take the wires to different houses right and they actually built a place storage where there were like thousands of batteries and they took the wires to different houses and they supplied electricity they found that the bulb stopped glowing if you go a certain distance and beyond and the reason behind that was electricity যখন তারতে যাচ্ছিল if it was very far away from your house the wire used up all the electricity, all the energy. So by the time it reached your home, it was all gone. So the distance became a limitation. But cities started to grow too fast. You couldn't keep up with pace. So you need more batteries now. And then they realized that they can also produce electricity very easily using what, a generator. And that's when they realized that you can take AC supply, all right, and use a thing in the middle called a transformer, which can make the voltage go up and the current go down, and you can transfer this over thousands of kilometers with less than like 5% loss. And that's when we realized that the future must be what only? AC. And since that day, echono AC use kora hoy. I'll give you a simple example. Echono keno AC use kori amra. Solar panels, right? Solar panels hocche kintu electricity যখন generate করে, they produce DC power. So there are a lot of solar farms out there, like China, India. Like there's a solar farm that's like half the size of Dhaka. Like there's solar panels everywhere, right? They produce insane amounts of electricity, but they produce what electricity? DC. ওদের এখানে একটা জিনিস ইনভেস্ট করতে হয়. It's called an inverter, or basically DC to AC converter. So a DC টাকে নিয়ে they use capacitors and everything else to convert the DC to what supply? AC, and then they can transmit it. Because why? If you try to transmit DC directly, কি হবে? Loss হয়ে যাবে. So the grid system out there, right, must work on your what supply? AC. Now comes the interesting problem. There are two power stations out there, and they're producing AC supply. একটা generator খুব জোরে ঘুরতেছে, আর একটা জেনারেটরটা একটু আস্তে ঘুরতেছে, because একটা হাইড্রোইলেকট্রিক wind speed খুব কম, hydroelectric অনেক বেশি. If you put both the currents into the supply, right, a strange thing happens. If one of the supply has a frequency that's opposite to the other, like the waves, out of phase, what do? Cancel out, and interference হয়ে দেখা যাবে যে power cancel হয়ে যাচ্ছে. So বাংলাদেশে ঢাকাতে যে gridটা, it comes from 3-4 places like Ashuganj, Keranganj, you have Kaptai sometimes, you have other places. সব জায়গাতে power আসে, উত্তরাতে কিছু সাবস্টেশন থাকে, ওইখানে ওরা কালেক্ট করে। যদি out of phase হয়ে যায়, তাহলে যেটা হবে, when they come and meet, right, they'll actually have no output. So they had to come up with a solution. So the solution was all the generators in Bangladesh, right, they're capped মানে ওদের একটা speed limit set করা, and the speed limit for rotation is 50 hertz. And that's the reason why when you look at the light, they flicker at what frequency? 50 hertz. একটা 100 হলো, একটা 50 হলো, তাহলে they'll have a mismatch, and it's a problem. এটা অনেকের বাসায় হয়, ওই জেনারেটরের ফ্রিকোয়েন্সি যখন নষ্ট হয়ে যায়, এবার লাইটস হঠাৎ করে ফ্লিকার করা স্টার্ট করছে। অনেক সময় আইপিএস এর সেম প্রবলেমটা হয়, স্টার্টস ফ্লিকারিং। সো এই ফ্লিকারের জন্য যেটা হয়, ইউ হ্যাভ energy loss. তার জন্য all power station by design is capped at what frequency? 50, except for the US. ওখানে the system is very different. ওরা 60 রাখে, because 60 হলে faster rate মানে কি more electricity production, and ওরা high voltage believe করে না, ওরা high current believe করে. So you'll find that if you buy some appliances from the US and bring it to any other country, right, they usually get fried out, because they're not accustomed to the high voltage we have, they're accustomed to the high current we have. So a grid system is very important. I mean, can I background it dilam, because let's say you want to go into electrical engineering, right, the most beneficial field out there is power sector. মানে these মানে electronics এর যে ফিল্ডটাতে power is the most lucrative one, because power লাগবেই সবার, there's no way out of this, right? ওইখানে this is what you're going to study, like the grid system. যেমন এখন currently একটা জিনিস চলতেছে, it's called a smart grid, and smart gridটা বাংলাদেশে নাই, but অনেক কান্ট্রিতে আসছে. So let's say you put a solar panel on your house, তুমি বাসার solar panel is producing a lot of electricity, and you go on a vacation, তোমার solar panel কি electricity produce করবে? Yes. No, কেন? হ্যাঁ, but ধরো তুমি ভেকেশনে চলে গেছো, but খুব ভালো সানশাইন হচ্ছে, it produces solar, your electricity, right? So in a smart grid system, you will get paid for it, because tomorrow solar panels will now feed the what? The national grid, and they'll actually pay you money for it. So এটার জন্য USA, Canada, Australia, Europe, if you put up a solar panel on your house, right, you can actually fix it to the main grid, মানে the national grid, and তোমার যখন electricity use হচ্ছে না, excess যেটা produce হচ্ছে, the government buys it from you, and you actually produce more electricity from it. In fact, it pays you back for all your investment. Okay, so it's actually like your mini power station.
How's it paid?
It's pretty good. I mean, what I've heard is that if you invest into a full rooftop of solar panels, in 5 years you'll like pay it back, and next is just earning money from the sun for free. That's literally what you're doing, right? So that's the power. Now, ওই power যেটা generate হচ্ছে, আমি কেন এত কিছু বললাম, is because our frequency more or less always will be 50 hertz. Because our UK system, the UK is also 50 hertz, yes? So high current is useful when you have power hungry appliances. So Bangladesh don't have a problem if you want to use like a pneumatic drill. You know what that is? Rasta drill করার জন্য একটা জিনিস ইউজ করে, হ্যাঁ, ওটার জন্য ট্রান্সফর্মার লাগাতে আলাদা, because ওটা পাওয়ার করা যায় না from our supply. USA তে backyard people just use it randomly. They want to make a hole somewhere, they'll just bring one of those drills. কেন ওদের current is so high, it can power those heavy appliances. So industrialist mentality ছিল there, so they went for high current. Okay.
So like always DC is
always. তারপর এটাকে একটা মেশিন দিয়ে কনভার্ট করে এসি করতে হয়। কোথায়? ইউএসএ তে পাওয়ার লস? না না, ওরা ট্রান্সফর্মার যখন ট্রান্সফর্ম করে ওই ভোল্টেজ বাড়ে কারেন্ট কমায় দেয়। তোমার বাসায় যখন দেয় তখন কারেন্ট অনেক হাই রাখে। সো ট্রান্সমিশনে কিন্তু দে আর জাস্ট লাইক আস, they'll take to very high voltage, very low current. বাট আমরা কি করি, আমরা 220 ভোল্টেজ যাই, ওরা 110 এ চলে যায়। তো 110 এ যদি ওরা চলে যায় তাহলে কারেন্ট আরো বেড়ে যায়। I don't know. This okay, look at this. This is my time period T. একটু আগে আমরা এটা শেষ করি, and this is my maximum voltage here. আমরা maximum voltage থেকে হচ্ছে V naught বলবো, and we will now form an equation here. So the equation for an AC supply, এটা carefully শুনো, is V equals to V naught sine omega T. And omega comes from where? If you remember your circular motion, what is omega? 2 pi f or 2 pi by t, right? So if you further break down eventual equation for an AC supply looks like this. So I'm going to V equals to V naught sine 2 pi f. F is what? The frequency of my supply into t. Question, what can you do with this equation? So let's say you want to know the voltage at a given time. You just plug in the time here. But I want the voltage fluctuate. So what if I want to know what's the voltage at that instant? Just taking a time to frequency, you'll know what your value is. Okay. So this is the equation for an AC supply. AC supply. Yeah, so nature has a tendency to go for circular motion equations. You find it in a lot of places, okay? And this naturally comes from simple harmonic motion because what's happening in the generator? Spinning in circles, right? So okay. Bolo question. So this is the equation, V equals to V naught sine omega t. Just a disclaimer, this can also be written as what? What's an alternate to this equation? V equals to V naught cos omega t. Okay, but এটা এই গ্রাফের জন্য applicable না because আমার যে গ্রাফটা provide করছে is a what function? Sine, but cosine ও দিতে পারো, right? And you can still use it. Okay. No, I mean we do use tan, but not as a time function. There's tan এর মাঝখানে একটা point আছে where it's undefined, so you can't cross that time axis. Yeah, we only use that. No.
So I have a question. Normally fans rotate clockwise. What a fan is anti-clockwise.
দুইটাই করতে পারে। আসে তোমার হচ্ছে ডিপেন্ড করে ব্লেডের উপরে। এই ব্লেডের ডিজাইনটা হচ্ছে ফর ক্লকওয়াইজ রোটেশন। সো এটা অ্যান্টি ক্লকওয়াইজ যদি ঘুরে বাতাসকে উল্টা দিকে নিয়ে যাবে। লাইক এন এক্সস্ট ফ্যান। এক্সস্ট ফ্যানের ব্লেডগুলো দেখো খুবই টুইস্টেড থাকে। ওরা এভাবে টুইস্টেড করা থাকে যে দল টেকিং এভরি এয়ার আউট। এখন এক্সস্ট ফ্যান যদি রিভার্স করো তাহলে ভিতরে চলে আসবে। আর এটা কিন্তু ইউজ করে হচ্ছে ইন ইয়োর এরোপ্লেন যে প্রপেলার্স গুলো, শিপে টারবাইন্স থাকে না, তো শিপ কেমনে রিভার্স যায়, ও জাস্ট হচ্ছে ব্লেডটাকে কোন দিকে স্পিন করে উল্টা দিকে, তখন থ্রাস্টটা এইদিকে সরে যায় and the ship starts to go back. হ্যাঁ, ওই উল্টা দিকে রোটেট করে and it produces reverse thrust. It's breaking thrust. It's like slow the blade down. Yeah, it's you basically went beyond capacity of the battery. Okay, let's apply this. সবাই একটু স্ক্রিনে দেখা একটা এক্সাম্পল দিয়ে বুঝাই কেমনে এটা ইউজ করতে হবে। So you have this scenario here where you're provided with AC supply. AC supply কেমনে draw করতে হয় ওটা একটু শিখাই দেব তোমাদেরকে, okay? So the official way of drawing an AC supply is like this. There are two dots like that. মাঝখানে কি draw করবা? A wave like that. And অনেক সময় দেখবা যে এরকম থাকে, অনেক সময় এরকম থাকে. These are different symbols of supply out there. If it's a flat line, just a flat line, it's a what supply? DC, right? আর ওইটা হচ্ছে হলো curve. আর যদি flat line with dots থাকে, it's rectified. And it was AC, it was made into DC, okay? But আমাদের just AC থাকবে. আর always when an AC supply is provided, they'll write two things at the top. একটা লিখবে হচ্ছে, let's say এখানে 400 volts and 50 hertz. It's a international standard. What does it mean? So the 400 volts that you see here, it means which voltage? Voltage to fluctuate, right? So what is the 400 volts here? It is always the peak voltage. So তোমার সবচেয়ে highest voltage যেটা provide করতেছে ওইটা হচ্ছে provide করে এখানে ওরা। আর এই যে ভ্যালুটা দেখতেছো, the 50 hertz, that's the watt of your supply, frequency of your supply, F of supply. So whenever there's an AC supply mentioned anywhere, they'll have to provide these two information for you. Now let's say I take this AC supply and I connect this to a resistor, like a fixed resistor, and I want to find out the current value here. So আমার এটা resistance হচ্ছে 220 kilo ohms. My voltage is provided here. I have a question for you. Questionটা হচ্ছে, find I at time 0.08 seconds. So at 0.08 seconds, what is the current in this circuit? So if I have an ammeter here, what would the current be at 0.08 seconds? আগের ফর্মুলাটা আচ্ছা করে দেখো কি আসে। Not yet, but you can. Equationটা দিচ্ছি। Equationটা হচ্ছে here. Not complicated. The second part is complicated. Rectification and rectifiers, smoothing. তোমাদের কি মাস্টারমাইন্ড স্কুল বন্ধ এখন? When does it reopen? So তোমাদের হচ্ছে লাস্ট চ্যাপ্টার করাইছিল হচ্ছে নিউক্লিয়ার ফিজিক্স, কোয়ান্টাম। আচ্ছা, yeah, then I'll catch up with school by that time. Oh wait, তোমার হচ্ছে নিউক্লিয়ার মেডিকেল এন্ড অ্যাস্ট্রো বাকি। কি আছে অ্যান্সার? 0.02 ampere. Okay, so the answer is কিছু না করেই বের করা যেত, it's 0. And the reason why it's 0 is because if it's a sine function আর তোমার যে frequency 50 hertz হয়, time period কত? 0.02. তাহলে our 0.04, our 0.06, and then next stage 0.08 যখন হবে, what is the value once again? 0. Now let's prove it mathematically. দেখি কি হয়। So এটা কেমনে solve করবে একটু বলি তোমাদেরকে। I want current, right? There's something called the Ohm's law, which states that V equals to IR. So this is the Ohm's law. It is applicable here because we are using a fixed resistor. So I can say that এখানে যদি replace করি, I can say that IR is equal to I maximum R sine omega t as well. What cancels out? The R. Achha. And as a consequence, we find that the equation for current variation in your circuit is also the same as what? The voltage. So voltage হচ্ছে কি ছিল? I V equals to V naught. This is I equals to I naught sine omega t. So yes, some of you would figure it out randomly, but it syllabus or এখন দিয়ে দিছে that the equation for current is also the same. Okay, so if you ever want to find the fluctuation in your current, you can use this equation. And then we'll apply our question requirement. So আমরা equation এটা গুছাই, আমাদের equation বানানো হয় নাই. By the way, if you're very lucky, they'll give you 3 marks এর জন্য just write the equation for 3 marks. Okay, so এখানে equationটা 3 marks এর জন্য কি হবে? I equals to, how do I find I naught? V equals to IR. So I equals to what? V by R. So what's my maximum voltage? 400. What's my maximum or my resistance? 20,000, right? So এটা হচ্ছে V equals to IR করে we can actually find the maximum current, which is going to be 400 divided by 20 into 10 to the power 3. How much is that? 0.02 ampere. So I equals to 0.02 because 0.202 is my maximum. Sine omega. Omega is 2 pi by t. I know my frequency, so I can use 2 pi f. So 2 pi 50 times t. এটাকে decimal নিয়ে আসতে হয়. Okay, you can't keep it in pi. So I equals to 0.02 sine, what's 2 pi 50? 31.4? No, 6, yeah, maybe. 314. Huh, what do you have? 100 pi. Yeah, so 314 t. Yep, that's the equation. And exam for this, they can give you up to 3 marks if you're lucky. বললাম তো সবসময় দেয় না, তাহলে হচ্ছে রিভার্সটা করতে বলবে যে ইকুয়েশন দিয়ে দিও, draw the graph and label all the parts. So yeah, do you understand the concept here? কি হচ্ছে, so you can use the current equation and form this one. By the way, exam কিন্তু এটা লিখে আসে না, মাঝে মাঝে ওরা বলে যে write down the formula for the current, right? And students will just write that and they'll stop. That is not your answer. What is that? That's the template. মানে এটা টেমপ্লেট মানে কি এরকম দেখতে হবে, বাট I naught এর ভ্যালু জানো তো, ওমেগার ভ্যালু জানো তো, ওগুলোকে বসাতে হবে কিন্তু. That's where the marks come from. Okay, right. So that is more or less the first part. এখানে আমরা কিন্তু দুইটা জিনিস পড়ে ফেলছি, but I'll be teaching you something else now, so এটা ইম্পর্টেন্ট, ওটা দেখে যাবো আজকে আমরা. So we are done with this. দেখো তো বুঝো নাকি time period, frequency, peak value. Are you clear? Peak value টা কি? Yeah, highest value. And this is x equals to x naught sine omega t. Or can x this say you can replace the x with what? Yeah, v or I. আর কিছু না কিন্তু. Okay, but এই জিনিসটা একটু বুঝাই দাও আমাদের নাম্বার 3 টা before we wrap up today. এটা খুব important. Okay, to carefully শুনো. So the problem with AC supply is that there is no equation for AC supply. Let me clarify. To carefully শুনো. Okay, why is the maximum current 0.02? V equals to IR use করতে হবে. So why are there no equations for AC current? Because AC current by design mathematically can't be solved properly. I'll show you why. So let's say I have an AC supply like this, and this is the fluctuation of my voltage, and I want to find power generated. Can you tell me the equations of power out there? There are 3 equations of power in electricity. No, electricity. P equals to VI, V square by R, I square R. So এটা একটা voltage fluctuate হচ্ছে, আমি তোমাকে যদি জিজ্ঞেস করি tell me what the power generated is by this supply, right? So তোমরা কি করবা? তোমরা ইউজ করবা P equals to V square by R because তোমার resistance ধরো আমি দিয়ে দিলাম. What voltage should I use here if I want to find the average power? Because you have to understand এখানে কিন্তু power fluctuate হচ্ছে, voltage fluctuate হচ্ছে না. So at peak value I'll have maximum power. At let's say a point at the, what is my power output? 0. So if somebody asks you find the average power here, what voltage should we use? Peak voltage. Peak voltage যদি use করি, that's not bad actually, but এখানে একটা problem আছে. তুমি peak voltage use করলা and তুমি একটা value পাইলা power এর জন্য, is that value for power going to be there always? না, তাহলে wouldn't that be an overestimate? তো আমার যদি peak value তে power দেওয়া হচ্ছে 500 watts, is it correct to say that this device always gives you 500 watts? No. তাহলে কি নিব? Standard deviation. How? Divide by 2. What divide by 2? Acha, that's not bad actually, but that would be correct answer if your supply was a what wave? Square wave, because the square wave, the divide by 2 gives you average, but this is a sine wave. Where is the average of a sine function? Because if I draw a line in the middle, as you just suggested, right? Do you think that the area here and the area there is same? No, so this is not the average, right? So what's the average of a sine function? What? There's no average. Okay, I'm going to explain, Corey. First of all, let me clarify something here. Carefully, it's important. Okay, chapter main part. So screen it. Let's say this is the power generated here. I mean, power to be right, with whatever we have. And then mathematically, I also find the power generated there. Oh, so you can't see it? Acha. So what happens is you have these increases. So what's happening here is that you have these areas here. Now, I'm going voltage value to name, and I consider these areas for my power. Your answer would be 0. Can 0 ashbe? Because if you look here, this is 500. What is that? Minus 500. Eta minus plus 400. This is what? Minus 400. Eta active value. Eta active value. So the point is, if I take the average of all the voltage here, what's the answer? 0, right? So I'm going to voltage answer key as 0. So they have found a solution here. Listen carefully. Solution the key. Solution ta hocche, none of the equations we have in electricity works with AC supply. Keep that in mind. Tell helpful of it that AC supply doesn't work in any electricity equation. What are the electricity equations? You know, V equals to IR, P equals to I square R, V square by R, whatever equations you know, Q equals to IT. None of them work with an AC supply. So there's actually a way to convert the AC supply to an equivalent DC supply. Maneta ki to boli. You can convert this graph into a DC supply that will do the exact same thing as your watt supply, AC supply. Take a DC equivalent of an AC supply. Mane hocche, you're going to take this graph and generate a DC graph there, which will do the same thing to your appliance as the watt supply, the AC supply. What does that look like? So what you know, the voltage value that you get here is going to be V max of your AC supply divided by √2. A value ta V naught by √2 will give you the same output as this graph out there. So I'm going to clarify, it's a little confusing, so carefully, let's say I take this AC supply and I connect to this lamp right now, and you see the lamp working, you see the brightness, you see everything it's doing, right? I replace the AC supply with this DC supply to this lamp, right? You'll see that it does exactly the same thing. Brightness same, the way it works, the time it lasts, same way. So we can say that this supply that you see here is a DC supply, but this is the watt of that AC supply, equivalent of it. Can we agree? Once I get this value here, where can I use this value? In every DC equation that we have. So the rule is that whenever you're given an AC circuit, listen carefully, whenever you're given an AC circuit, you first have to convert your AC values to a watt value, a DC value, and then use it in your equation. Etake bola hoy DC equivalent of an AC supply. And eta use kore you can find power, whatever you want, right? Shob kichu kaj korbe. So etake bola hoy, there's a name for this value. You have heard of this before. Yeah, this is called VRMS. And RMS er mane ki? Root means square, and root means square mane ki? No, not the process. What does it mean? Yes, it's an average. Okay, so this is the correct average out there, and we use this average of plus minus দুইটা involved থাকে, if you remember. Oh, এটা হচ্ছে derivation আসছে। আমরা এখানে করবো না, but once you do the RMS of a sine function, it becomes 1 by √2. Follow? No, the AC properties like the voltage, the power, the current, you can convert that into an equivalent DC circuit. So let's say this battery, right, is a DC battery, and I connect my lamp to this DC battery. There's also an AC supply where I connect my lamp. If both the lamps do the same thing in terms of brightness, not flicker, but in terms of brightness, I can say this AC supply and these DC supply are same. But then you'll notice their values are not the same.